Hi everyone, it's Mads again and welcome to the part 6 of our lesson number 2, still in addition of vectors of module number 2 of this week. Since we've done discussing about graphical method and it's time for us to move on to the next topic, and our focus now in this session is about analytical method. I will explain this one briefly so that we can utilize our time in doing sample problems. In analytical method class, we are no longer in need of exact measurement in dealing with vectors. So that means we can approximate the value of all vectors that we have in solving the magnitude and direction of the resultant vector. So we just simply use our mathematical skills in trying to find the resultant vector of the following vectors. Okay, before we proceed to the sample problem class, let us try to recall our basic trigonometric functions so that we can easily deal with vectors, particularly in solving the magnitude and direction of the resultant vectors that we have. For example, we have here a figure or a right triangle, assuming that we have here a right triangle, and we label each of the side as, for example, in this side of the triangle, side A, and this one is side B, and this one is side C, and we have here a angle or theta. Remember, just recall this one when dealing with basic trigonometric functions because this will help you a lot in dealing with analytical method. So we have expression of the first one is so, second is ka, and last one is toa. Basically, if we try to get the ratio of each of the side here, we will arrive at this expression here. For example, for the term so, that's stands for sine theta equals to opposite. The opposite here class is the side B, and then the hypotenuse is the side C here, the longer side of the triangle. That means the expression so is equals to this formula here. And for ka, the ka here is equals to cosine of theta. Cosine of theta is equals to adjacent. This will be our adjacent side A. Adjacent over hypotenuse. And for toa, that's tangent theta equals to opposite divided by the adjacent. Flipping this formula here, that means if you get the reciprocal of this one, we will arrive at the another formula in dealing with right triangle. Like for example, if you flip this one, you can get cosecant. Cosecant of sine is just a reciprocal of this one. Right hypotenuse over opposite. That is not the focus of our discussion. I just want you to remember this term here, so toa, and this one, because we will be applying this in sample problems that we have. So for basic trigonometric functions, relating this one into vector, for so or sine theta, this is sine theta is equals to opposite, that's A, over that's B over C. So this is just B equals to, if we relate this one into vector, this B becomes vector B, and this C here is just B equals to the resultant vector. So that becomes resultant vector. And for cosine theta here, this is equals to adjacent, that's A, over C, and that's that becomes vector A over resultant vector. And for tangent here, that's equals to tangent theta is equals to vector vector B over vector A. That means if we rewrite this one into an vector formula, this becomes sine theta is equals to vector B over resultant vector, and this one cosine theta is equals to vector A over resultant vector. is try to recheck adjacent. Okay, it's correct. And this one is tangent theta is equals to vector B over vector A. So this is, or this formula here or expression here will be the one to help you to solve the, or to find the magnitude and direction of the resultant vector as we go along in our sample problem. Now, remember that in finding also the hypotenuse of the triangle or the resultant vector of that, if we have a situation wherein side A and side B are given, so we can just directly use the Pythagorean theorem in solving that. By the way, it doesn't matter what formula or expression you're going to use, still it will give you the right answer if you perform your mathematics correctly. So in Pythagorean theorem, relating this one into our vector, so C here is, this becomes resultant vector squared, and this is equals to A here, that becomes vector A square, plus B here, that becomes vector B square. So if the problem is, for example, vector A and vector B are given, and we're asked to find the resultant vector of that, and we can directly use this one. Or else, we will consider using one of these formulas that we have here. Okay? You can post this video and copy this one, because this is the very important formula that you're going to remember, and if you can memorize this one, you try to memorize, because it will help you a lot in dealing with analytical method. So let's try applying those concepts that we have learned from the derivation or from our basic trigonometric functions. Now, assuming that we have here a sample problem, the problem is solve for the magnitude and direction of resultant vector of the following vectors, given the value of vector A is 30 newtons east and vector B is 40 newtons north. This time we don't need a scale, because we're dealing with analytical method, and as I said a while ago, we can just approximate the value. But let's just be more realistic. So for example, we have here a value of vector A that's going to east. So let's try to plot our vector here. So this is going to east, that's 30. So I just have to plot my or draw my vector here. So assuming that this is my vector A, and my vector B is 40 newtons going north. So from this one, we'll draw my my vector B going upward, something like that. And our resultant vector is located here again, from the tail of the first vector to the head of the last vector. So I will just draw my resultant vector here. So this is now our resultant vector, and this will be our direction, and this will be our vector B. So we have already draw the two vectors that we have. So we already form a right triangle. Now to do that, let's try to solve first the resultant vector, since as I said a while ago, if both sides are given, this one is 30 newtons and this one is 40 newtons, and we can just simply go to the Pythagorean theorem and we'll apply that automatically in this problem. So solution, resultant vector here is equals to vector A square plus vector B square. This is equals to resultant vectors equals to square root of vector A square plus vector B square. Okay, now we have here, this is now our formula. This will be the equation that we're going to apply to find the resultant vector of this one. The next one is to substitute all the given value here. Resultant vector is equals to square root of, for vector A, that's 30 newtons square, plus for vector B, that's 40 newtons square. This is equals to square root of 30 times 30 plus 40 times 40, 30 squared plus 40 square, that will give you approximately 2,000. Yeah, I try to check this one in your calculator. 2,500 Newton square. This is equals to 2 times square root of 2,500 will give you, you can recheck this one in your calculator, will give you 50 newtons. So resultant vector here is equals to 50 newtons. If we get the square root of this one, this will cancel out to the index of our square root sign here. So that's why the remaining unit here is n. Okay? So that would be our resultant vector. Now let's proceed to, this is solve for resultant vector. Solve for direction. So since both sides are given, and if we go back to this equation here, we can use tangent function because all sides, side A and side B, are given. So we will apply tangent function here. Tangent theta is equals to vector opposite vector B over vector A. Substitute. For vector B, this is when it comes to this formula here in vector class, these are all absolute value. Okay? Remember that these are all absolute value. So this is equals to 40 newtons over 30 newtons. So we will cancel out the unit here and unit there. So 40 divided by 30, that would give you tangent theta is equals to, that would give you I think 1.33. So inverse tangent, that means when you transfer this one, this function here, that becomes inverse function. So this is theta is equals to inverse tangent is multiplied to 1.33. And this is equals to, tangent theta is equals to 53 degrees. You can recheck this one in your calculator. 53, no unit. That's 53 degrees. So that would be the answer. How to press this one in our calculator? This term here. How to press that in our calculator? I will just put here. You just simply press shift and then press the tangent function, and then you can press the open parenthesis and then 1.33 and press again the close parenthesis and equals. this will give you 53 degrees. So I don't have a scientific calculator, but I already solved this one. You can recheck this one and so that you can evaluate or you can recheck if our answer here is correct. Now, to express our final answer, I will just put here our final answer using our red ball pen. So our final answer is resultant vector is equals to, get the value there, 50 newtons. What's the first direction? East. What's the angle? 53. 53 degrees. What's the last direction? North. So the answer is resultant vector. To answer this this question here, magnitude and direction of resultant vector is equals to 50 newtons is 53 degrees north. So 50 newtons is 53 degrees north. That would be our answer. So this is our final answer. Post the video class and copy this one. That would be all. Thank you so much and see you in the next video.